So to actually just look at what your double integral is going to look when you change the polar coordinates. All right. Again, we're going between, for our radius, some a and b, and for theta, we're going in between two angles, alpha and beta. All right. Now, when we're writing this, what I want you to do, and then again, it's going to be in between, one rotation. This is what this means. Our beta and our alpha, they're going to be angles that are going to be from 0 to 2 pi. All right. All right. Now, it's always going to be set up this way. I know, we could use Fubini's theorem and have x or y's first or last. All right. Here, our d theta is always going to be the outside integral. And the reason why it's the outside integral is because theta is always going to be a constant. All right. And that's really nice because theta is always a constant. It's going to make this work really easy. And again, we always want our constants on the outside. The a's and b's here, these could also be functions. I don't know if we wrote it down. No. Well, yeah, there we go. Here we have some function down there. So a's and b's could be functions for your radius. All right, what defines our outside region and our inner region. And so we're just going to set up this way again. Notice r dr d theta. So when we change to polar coordinates, we have to add in this r. All right. And again, that r was brought to you from when we were actually doing the area of a sector. We had that extra r there, so we have to add in that r. The best way to see it is to do a proof, and it's going to be, we're going to use the Jacobian to do that, but you don't know what the Jacobian is, and we'll get to that later. Next week, I think we'll talk about the Jacobian. I think we'll get there. If not, we'll get there the week after. All right, so now all we want to do is we have a region R. So example 1, we want to decide to use polar or rectangular, and then we're going to write the double integral. And that's basically it. So looking at it, I hope you notice, hey, this looks like it'd be easy to use polar, and of course it is. So let's go ahead and define the region. So the region here is going to be R theta, because we're going to use polar, and our r looks like it's going to go from 3 to 6. So 3 is less than r is less than or equal to 6, and our theta, it looks like what we're doing is we're going from that angle, again counterclockwise, so we're going from negative pi over 2 to pi over 2 for our theta. All right, now let's go ahead and put it in polar. So again, doing the thetas on the outside, so negative pi over 2 to pi over 2. And then we are going to use our r's from 3 to 6, and f of x, which is going to be r cosine theta, f of y, which is r sine theta, r dr d theta, r dr, like a little pirate. That's it. We're done. All right, we don't have to integrate it at all. We're just finished, and that's using polar coordinates. So hopefully you enjoyed it. I mean, this makes your life so much easier. All right, let's look at example 2. So example 2, we're going to evaluate the given integral by changing into polar coordinates. So again, what's best to do is to go ahead and graph this. And so here's our surface, 2x minus y. There's our surface, 2x minus y, where r is the region in the first quadrant enclosed by the circle x squared plus y squared equals 4. And we have the lines x equals 0 and y equals x. All right. So let's draw that enclosed region, because we don't really, we have the surface, but we're just going to draw the enclosed region because that's what we're going to integrate. And x squared plus y squared equals 4, so that gives me a radius of 2. Let me draw this bigger. I have all this room, and I have such a small coordinate plane. Alright, let me draw some straight lines. Watch it go straight. Let me draw some straight lines. And why I decided to make that smaller, it's beyond me. Alright, so we're going from, it looks like 2 Now it says in the first quadrant, and we're enclosed by x equals 0. All right, so let's draw the circle. All right, watch this. Boom. Nice little circle. And we need our region x equals 0. X equals 0. Well, I already have red. X equals 0 is going to be this region right there. And y equals x. So pretty much cutting that in half. So there's y equals x. And so this is the region that we're working with. All right, now let's go ahead and define everything. And so now our region equals our region, going to define that as r theta, where our r looks like it's in between 0 and 2. And our theta, again, this right here is where our x's and y's are equal. So hopefully that you notice that, oh, that's just pi over 4 for theta. And this is going to be pi over 2 for theta. So we're going from pi over 4 to pi over 2. All right, now let's go ahead and just set everything up. So we're going to integrate this. So again, we're doing our thetas first. So from pi over 4 to pi over 2. Doing our integral for r, which is going to be 0 to 2. And now it was 2x minus y. We're going to go ahead and say 2r cosine theta for x minus r sine theta for y times r dr d theta. All right, now what's really nice about this, all right, is I can go ahead and I can pull out my r's. So I can break this up and integrate from pi over 4 to pi over 2 because there are two functions multiplied by each other. I can pull this r out. And so I'm going to have pi over 4, 2 cosine theta minus sine theta, and then d theta. And then on the other side, I can have from 0 to 2, it looks like r squared dr. And so again, I just broke up. I noticed, oh, hey, there's just two functions, multiplied. I can pull the r out and be r squared and have 2 cosine theta, sine theta. And because they're of now just each variable, I can go ahead and separate that through multiplication, and I can integrate these by themselves. And so let's go ahead and integrate. So we're going to integrate 2 cosine theta. That's going to be 2 sine theta. Minus, or integrate a negative sine theta. If it's negative sine theta, it's going to turn into plus cosine theta. Going from pi over 4 to pi over 2. And then times, and then from 0 to r squared, it's going to be 1/3 r cubed. From 2 to 0. All right, and then again, we're going to go ahead and substitute in. So when I substitute in 2 sine pi, when I plug in 2 sine pi, it's just going to be 2. When I plug into cosine pi, that's just going to be 0. When I plug in pi over 4, 2 sine pi over 4 is going to give me square root of 2. And then plug in pi over 4 plus cosine pi over 4 is going to be minus square root of 2 over 2. Then times, and then plug in 8/3 to the right. And then I have 0. And so now just do the math. It's going to be 16/3 minus 4 radical 2. And that's it. All right. Again, the rest is just computation. You should be able to do that fairly easy. And there's my answer.